At first blush, you may not expect to do a lot of writing in a chemistry laboratory class. After all, in a chemistry laboratory class, aren't you supposed to go in, mix different liquids and solids and gases together, and then maniacally laugh as they bubble and change color and smoke? Isn't that the purpose of a laboratory class in chemistry? But as a professional chemist, as a real scientist, and even if you're not becoming a chemist, a professional chemist, if you're becoming a scientist, and I would include doctors and dentists and pharmacists as professional scientists, there are few things that you will do more than write. Now, I want to talk about why and how this is especially appropriate in a laboratory class. And I think it'll give you some insight into what a laboratory class is really about and what doing real science is really like. So there's sort of a divide. In lecture classes, there's a lot of information that's known. There's a lot of known information. Now that's stuff that humanity had to claw away from the unknown over centuries, over generations. It's things that people had to come up with brilliant experiments for one generation at a time. They had to figure things out. And so in the lecture class, you sort of climb onto the shoulders of those giants of humans that learned these things. You climb onto the shoulders of those giants and you view the vast panorama that they've given to you. And there's a lot that people have known, have learned, and that they know now. And so in lecture classes, you sometimes get a sort of false impression about science. You get the impression that people know everything. After all, you have to spend so many hours for every week for so many years to catch up with it all. So it feels like people know everything. But when you become a real scientist, that paradigm completely shifts. Your whole value as a real scientist is to explore the unknown. People will only want you around to solve problems that people don't know the answer to yet. So although in lecture classes you're conditioned and trained to look for that known correct answer that people have figured out over centuries, in real science, you're constantly trying to figure out, you're constantly confronting the unknown. And you could almost even measure the progress you've made as a scientist by how much excitement and opportunity and thrill you get from that unknown. I think at first we're all very comforted by what we know. We see what we know and we think, oh, okay, that's safe, that's familiar, I can do that, I know, I'm at home in the situation. And the unknown sort of makes us uncomfortable. We don't know what's going to happen. It's nerve-wracking. But you'll know you've become a scientist because the known will still be interesting, but it'll become slightly less interesting. The unknown is what will have your interest and excitement, your curiosity, and your observation. So if the lecture classes focus on the known, here in the lab class, where we are sort of training to become real scientists, where it's a matter of you looking at the world around you, questioning it, and trying to come up with an answer to the question just on your own devices, we're going to be exploring the unknown. And so this class, this laboratory class, will largely be a matter of sort of like strapping you up with hiking boots and a walking staff, giving you the confidence to walk in any direction you want, and then to hear the stories you come back with after going on the adventures you go on. So real science, the excitement of science, you can measure your progress as a scientist by the excitement you find in the unknown. And that's where writing comes in. After all, if you know an answer, then you could just do everything can just be true or false. You write a number down, you write a measurement down, and people can see it and instantly evaluate whether it's true or false. But if nobody knows the answer, then what do? Let's say you test something out, you make a guess. That's a huge foundation of science. You make a guess, you test it out, and then what? You have the results of your test, and what happens next? How do you evaluate that? If nobody knows what's right and what's wrong, how can you evaluate the information you have? And one thing I want to point out here is that in real science, making guesses and making mistakes is like the blood life of a scientist. you make guesses, you come up with questions, you make guesses, and then, and oftentimes in science, instead of just trying never to make a mistake, in real science, sometimes you try to make as many mistakes as you can, as fast as you can, and just make sure you don't make the same mistake twice, and that narrows things down and gives you valuable information. But okay, nobody knows the real answer, so how do you evaluate the results, the information you get from those tests, from those experiments? And that's where the writing comes in. All you can do after you do an experiment is clearly communicate it to other people. And where truth, the truth, or what seems like the truth, knowledge, is something that exists in a world where things are known. In a world where things are unknown, what takes the place of truth is persuasiveness. So what's more persuasive? And it's your ability to write clearly and communicate your ideas clearly that will make your experiments and your results persuasive and useful to other people. So in this class, we're gonna do some writing. We're gonna learn to write a research article, a professional sort of type research article that would, in the same format, that would be published in a professional journal. And the reason why we're going to spend so much time practicing this writing is because as a professional scientist, you'll be exploring the unknown, and the value of your results in that exploration depends on your ability to clearly and therefore persuasively communicate them to other people. So the writing in chemistry is crucial, writing in science is crucial, because we're exploring the unknown. Nobody knows the right answer, so all we have is our ability to think methodically and communicate clearly. All right, so in future videos, we're going to talk in more detail about this and the nuts and bolts of this, but I just wanted to, because we're going to spend so much time on it, I wanted to have one video where we talked about why writing is such an essential part of chemistry, how it's, maybe sometimes it's tempting to think of math and science as separate from this sort of humanities act of writing, but the truth is, writing is a crucial part, an essential piece of training for a scientist.